A warm welcome to Module 5 of the Polygon series. Today we are going to explore naming of polygons. After this session, you will be able to name and classify different polygons on the basis of the number of sides they have. So let's go. Before we dig deeper into the polygons, let's quickly recap what we studied in our previous modules. Let's take these two polygons and classify them as regular or irregular. Keep writing your answers on a paper and then we will check our answers together. You can pause the video whenever you need to indulge more with the content. Okay, now let's go. Let's take these two polygons and classify them as concave or convex polygons. And now the last column. Let's take these two polygons and classify them as simple or complex. I'm sure you are ready with the answers. The first polygon on the screen is a square. It has all sides equal, all angles equal, making it an equilateral, equiangular polygon. Hence it is a regular polygon. And the polygon that we see on the screen now is exact opposite of regular, that is irregular polygon, because its sides are not equal. Moving on to the next section, this polygon is clearly a concave polygon. We can visually see the dent in it, giving it a reflex angle, and also one of the diagonals will lie in the exterior of the polygon. So it's a concave polygon. And this one is a convex polygon. The star polygon, as we can see, is not self-intersecting, is not overlapping its sides, so it is a simple polygon. And this is a self-intersecting or a complex polygon. Here I want to emphasize on one more point. A star can also be drawn in this way. If we draw the star the way it is shown right now on the extreme right hand side of the screen, then it is a complex polygon. For the simple reason because the sides are overlapping each other. So our topic at hand is naming a polygon. Did you know a polygon is named on the basis of the number of sides it has? Let's explore. Let us draw a polygon with minimum number of sides. So we'll take a line segment. And is it a polygon yet? It is not a polygon for the simple reason polygons are closed shape. That means we will require more line segments. So let's add another line segment. Have we reached there yet? Is it a polygon now? No, it is still not a polygon because polygons are closed shapes. So I think we'll require more line segments. Let's explore. Is it now a polygon? Yes, polygons are closed shapes drawn using line segments only. So yes, this is a polygon. So we have explored that the smallest polygon is a triangle and we can also write it as trigon. Now we will slowly and gradually remove the term poly or the prefix poly from gon and replace it with the number of sides. For example, the polygon that you see on the screen now has 4 sides. So this can be called a quadrilateral. Quadri means 4, lateral means sides. So it has 4 sides, or we call it a 4gon. So polygon, and in place of poly we are writing the number of sides. Now this polygon on the screen, you can count the number of sides and write the answer in the comment section. That's right. 1, 2, 3, 4, 5. It's a pentagon, or we can say 5gon. And this one. It is again a very common polygon you must have seen in the beehive. So it's 1, 2, 3, 4, 5, 6. 6gon, or in place of 6 you can write hexa. Hexa means 6 sided. So hexagon. Now this is important for us in case we want to explore how are we increasing the number of sides starting from the smallest polygon, that is triangle. Let's take a point outside the triangle to create a new side by joining two of its vertices to the new point. Watch as the new side is being created. Remove the original side of the triangle and we are left with a new shape. Can you count the number of sides? Absolutely right. It's 4 and the shape is a quadrilateral. But wait, there is more. Let us take another point outside this quadrilateral and join two of the vertices to this point to obtain another side. Now remove or ignore the previous side and now can you tell me what shape have you got now? Absolutely right. 1, 2, 3, 4 and 5. So let's check it once again. Keep counting, keep observing how we are converting a triangle to a quadrilateral by joining the vertices to a point outside it. So from a triangle we created a quadrilateral. We again take a point outside the quadrilateral, join the two vertices, and here we get the next polygon in order, that is the pentagon. All sides are not equal, so of course it is an irregular polygon. We will explore creating a regular polygon also in a very interesting way. If you want to try this activity yourself, you can pause the video and see if you can create a hexagon by adding a point outside the pentagon. Do share your results in the comment section. Now, again, it is important for us to give 2 minutes to the other polygons also because they also have a comprehensive views in the forthcoming classes. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 gone. Can you guess what is the prefix used in place of 8 or something related to an octopus? Absolutely right. It's octagon. Octa means 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 9gon is called as a nonagon. And observe the difference in the shapes, how the shapes are changing from flat to one more pointed. If you observe these 3 polygons on the screen, you will see only with 1 point increase, one side is getting increased. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10gon, also known as a decagon. Have you missed a polygon? Yes, 7-sided polygon. It's a special polygon. Why? Because it has got 2 names, heptagon and septagon, which at times confuses the student. So we have explored polygons. But what about circles? What do you think is the relation between circle and a polygon? Apart from the fact that circle is a perfect example of a non-polygon because of its curved boundary or curvature, does it still have a connection with polygons? Let's dive in and find out. Imagine we take a circle and divide it into equal parts. You may do this activity using a circular cutout. I have divided the circle into 5 parts. Now let's join the parts where the radii are touching the circle. You can see the radii are touching the circle. These are 5 equal parts, and because of the equal parts, the angles are also equal. With the blue line segments, I have joined the points where the radii are touching the circle. I've joined it. Since there were 5 parts, I have got a 5-sided polygon. And can you tell me which the name of the polygon and the classification of the polygon? Is it regular? Is it concave? Is it convex? And you can name it also. So number of equal parts that we had divided our circle into become the number of equal sides the polygon has. So we have created a regular polygon. In the previous section we were creating an irregular polygon. So let's draw the conclusion. As the number of sides approach infinity, polygons approach circle. You can see this interface also. We started from a triangle, and slowly and gradually as you increase the number of parts you're dividing a circle into, you are going to get polygons which are approaching circles. Now that this module is coming to an end, you have covered so many concepts of polygons that now I am going to mix up all the concepts and give it to you in MCQ. If a polygon has one or more interior angles greater than 180 degree, is self-intersecting and has 6 sides, it is a complex hexagon, regular pentagon, concave hexagon or concave pentagon. So when we read the statement one or more interior angles greater than 180 degree, we know it is not possible for it to be a regular polygon. So we are left with 3 options. Angle greater than 180 degree and is self-intersecting. Which kind of a polygon do you think it is? You may pause the video if you want more time with the question. Absolutely right. Self-intersecting can only be complex polygon. With 6 sides, it is complex hexagon. Which polygon has one of its diagonal in its exterior and is 7-sided? Convex heptagon, concave heptagon, regular octagon or irregular heptagon? You can take this question 2 ways. Either go ahead with 7-sided first. So which polygon is 7-sided? It is heptagon. So that means one option is out. And second is diagonal in its exterior. So can it be convex? Should it be concave? Or will it be irregular? Irregular polygons have nothing to do with the diagonals. For irregularity, we check the equality of angles and sides. Similarly, for convex, we check the self-intersection of sides. So diagonal in the exterior is because of the reflex angle, the kink or the cave. So the correct option is concave heptagon. This is a quick summary to name the polygons. You can check the number of sides with the prefixes for each polygon. If you want, you can take a screenshot. And for polygons with more than 10 sides, we can use n-gons. For 20 sides, 20-gon and so on. Stay in the video till the end to dive into the rapid fire round and show off your math skills. I am now leaving you with questions that will challenge your understanding. Put your pen to paper, music on or mute, whatever helps you focus. Take your time and let your math progress shine and reflect.